Welcome to the first video of the fifth module, that is numerical methods. In this video, I am going to do the introduction and what is interpolation. Finite differences. Consider a function y equals to f of x. Let x0, x1 is equal to x0 plus h, x2 is equal to x0 plus x1 plus h, etc. xn is equal to xn minus 1 plus h be the set of points at a common interval of h. Let the corresponding values of y equals to f of x be y0 is equal to f of x0, y1 is equal to f of x1, y2 equal to f of x2, etc. yn is equal to f of xn. The forward differences. The first forward differences of f of x denoted by del of f of x is defined as follows. Del of f of x is given by f of x plus h minus f of x, where del is the forward difference operator. So, first difference, that is del of f of x naught, is given by f of x naught plus h minus f of x naught, or del of y naught is y1 minus y naught. Similarly, del of f of x1 is given by f of x1 plus h minus f of x1, or del of y1 is given by y2 minus y1, and del of f of x2 is given by f of x2 plus h minus f of x2, and del of y2 is y3 minus y2. Similarly, del of f of xn minus 1 is equal to f of xn minus 1 plus h minus f of xn minus 1, or del of yn minus 1 is equal to yn minus 1. So, difference of the first forward differences are called the second forward differences. They are as follows. So, del square of y0 is given by del of y1 minus del of y0, and del square of y1 is given by del y2 minus del y1. Del square of y2 is given by del y3 minus del y2. Del square yn minus 2 is given by del yn minus 1 minus del yn minus 2. Similarly, the other higher order differences, namely the third, fourth, etc. are obtained and tabulated. Next is the interpolation. If y0, y1, y2, etc. yn be the set of values of an unknown function y equals to f of x, corresponding to the values of x, that is x0, x1, etc. xn, the process of finding the value of y for any given value of x between x0 and xn is called as interpolation. Also, the process of finding the value of y outside the given range of x is called as the extrapolation. Interpolation formula for the equal intervals. We have two types of interpolation formula. One is the Newton's forward interpolation formula and the other one is Newton's backward interpolation formula. The value of y equal to f of x at x is equal to x0 plus h is that yr is equal to f of x0 plus h is approximately given by yr is equal to y0 plus r delta y0 plus r minus 1 by 2 factorial into del square y0 plus r minus 1 r minus 2 by 3 factorial into del cube y0 plus etc. plus r minus 1 r minus 2 etc. r minus of n minus 1 by n factorial into del n of y0, where r is any real number. Next is the Newton's backward interpolation formula. This backward interpolation formula is used in order to find a value which is at the end of n, xn, near to xn, whereas the forward interpolation formula is used when it is before the midpoint, that is from x0 to the mid of the xn, x0 to xn. The value of y equals to f of x at x is equal to xn plus rh is that yr is equal to f of xn plus rh is approximately given by yr is equal to yn plus r del yn, that is nabla we call it as, plus r plus 1 by 2 factorial del square yn plus r plus 1 r plus 2 by 3 factorial into del cube yn it is by mistake it is yn. Here also it has to be yn. R plus 1, R plus 2, etc. divided by n factorial into nabla power n of yn, where R is any real number. Next, we will see the problems based on both forward interpolation as well as backward interpolation. Find y of 1.4 given that x takes the value 1, 2, 3, 4, 5 and y takes the values 10, 26, 58, 112, 194. Here we can observe one thing. X takes the value equidistantly, that is, the difference between x0 and x1 is always 1 and x1 and x2 is also same as 1 and x2 to x3, x3 to x4, etc. It will be same as 1. That will be taken as h value. Solution. Here we have to find y at x is equal to 1.4. Since the value x is equal to 1.4 is in the first half of the table near x is equal to 1, we use the Newton's forward interpolation formula and it is appropriate, and we shall construct the forward difference table. So now the forward difference table is done like this. Let us tabulate the x values, y values, del y, del square y, del cube y and del power 4y. So here x values are 1, 2, 3, 4, 5 and y values are 10, 26, 58, 112 and 194, and delta y is nothing but the difference between 26 minus 10, that is 16, and 58 minus 26, that is 32, 112 minus 58, that is 54, 194 minus 112, that is 82. Next, the second difference will be obtained by taking the difference of the first difference, that is 32 minus 16 will be 16, 54 minus 32 is 22, 82 minus 54 is 28. Next, the third difference is obtained by taking the difference between the successive values of second difference, that is 22 minus 16 is 6 and 28 minus 22 is 6. Now the fourth difference is obtained by taking the difference between the third one, that is 6 minus 6, which is equal to 0. So now we have obtained all these values is the table. We need to refer these values, that is 10, 16, 16, 6 and 0. These are all the values like y0 is equal to 10 and delta y0 is equal to 16. That is also same as delta square y0, and delta cube y0 is 6 and delta power y0 is 0. So delta power y0 is not required because it is already 0. Now let us see the forward interpolation formula and then we will substitute these values. We have the Newton's forward interpolation formula is given by yr is equal to y0 plus r delta y0 plus r minus 1 by 2 factorial into delta square y0 plus r minus 1 r minus 2 divided by 3 factorial into delta cube y0 and so on. For this problem, only up to the delta cube y0 is required. We don't require any other values because after that it will be 0. Here r is nothing but x minus x0 divided by h, where x is a point at which y is required, that is equal to 1.4, and the initial point is x0, that is given by 1. H is the common interval length, that is equals to 1. So r is calculated as 1.4, for which we need to determine minus x0 value, which is 1, and even the h value is 1. So when we do 1.4 minus 1 divided by 1, which is equal to 0.4. From the table we have del y0 is 16, del square y0 is 16, del cube y0 is 6 and del power 4 y0 is 0. Therefore y of 0.4 is f of 0.4, which is given by 10 plus 0.4 into 16 plus 0.4 into 0.4 minus 1 by 2 into 16 plus 0.4 into 0.4 minus 1 into 0.4 minus 2 divided by 6 into 6. On cancellation and simplification, we are getting 10 plus 6.4 plus 0.4 into minus 0.6 into 8 plus 0.4 into minus 0.6 into minus 1.6, which is equal to 14.864. Therefore, y of 0.4 is given by 14.864. This is the answer. Thank you.